let's put this all together. We have this big equation right here. Now you'll notice your exponents match the patterns that we've learned so far. So if this is to the 5th power, this would be to the 5th and to the 0, to the 4th and to the 1, to the 3rd and squared. So that matches our exponent. Then we have a plus b, so there's our numbers inside a, b, a, b, a, b. Now what we're focusing on is the coefficients, because the whole part of this thing has been finding a new way to calculate these coefficients. And technically we have a 1 there and a 1 there. And here's the new way. Turns out that this green coefficient in front is whatever your exponent is. So say it's to the 7th power. This would be 7 choose 1. And next one would be 7 choose 2, 7 choose 3, 7 choose 4, 7 choose 5, 7 choose 6. And then the last one would be 7 choose 7. And you can just put those into your calculator. So that is another way to find those coefficients in front. You can use the row of Pascal's triangle if you want. That's always there for you. Or you can use the choose button on your calculator, and it's whatever the exponent is, choose the next one in the row. Now, another thing I would like you to notice is whatever the number is here for the coefficient matches the exponent on the second parentheses. So this is n choose 2, and this is b squared. Those match. The number on top is always whatever your exponent is to the 7th power or whatever. The other thing I hope you noticed over time, even though I didn't explicitly point it out, is that the two exponents added together should total your final exponent. So like up here, when we had this example, if I take 4th and squared and add those together, that gives me 6th, which is the exponent that I'm looking at. So they should always add together to get your total exponent. So now that we've noticed all these patterns, we know that this bottom number matches the second one. We know the exponents add together, and this is always whatever exponent you're raising. We can now do more specific ones like this one. Find the 7th term in this expansion. So let's figure out what the 7th term would be. This would be my first term. This would be my second term. This would be my third term. And hopefully you've noticed from that these two numbers we highlighted in yellow are always one less than the term we're on. So this is the third term. So this is a 2 and that is a 2. This is the second term. So this is a 1. That is a 1. So if I want the 7th term, then this is going to be n choose 6. It's one less than the term number I want. And then I have my parentheses. I need my exponents. Remember, this one's going to match that one, 6 and 6. And they have to add together to get 10, because I'm doing to the 10th power. So 6 plus, that has to be a 4, so that those add together to get 10. That also means that this n is going to have to be a 10, because that's the power I'm going to. And now my last step is I can just fill in the a and the b from what I've got there. And that's how I can find specifically the 7th term. This is one less, this is one less. Those add together to get your 10th power, and your 10th power goes there. Now the beauty of all of this is now I can just type this into my calculator. So I can type in 10 choose 6. We learned how to do that last time. That's 210. A to the 4th, b to the 6th. And that's going to be the 7th term if I multiplied all of this out. So let's try example 8, last example of the day. we want to find the term that contains an x cubed, and we want to find the term that contains a y to the 5th. So let's write this out. Then I have something. Now the first thing I'm going to do is I know that this is raised to the 7th power. So both of these are going to be 7s. Next, I know that I want this to have an x cubed in it. So let's fill in our 2x and our negative y. 2x negative y, 2x negative y. I want the x to be cubed, so this is going to have to be cubed. And in this one, I want the y to be to the 5th, so that's going to have to be to the 5th. Now remember, these two need to add up to my 7. So if this is a 3, that's going to have to be a 4 to add up to 7. And if this is a 5, that's going to have to be a 2 to add up to 7. And our last pattern is this number should always match this number. So this is going to be a 4th, match those, and this one's going to be a 5th to match those. And now I can just simplify. So 7 choose 4 is 35. I'm going to cube both of those to get 8x cubed. Negative y to the 4th is just positive y to the 4th. Oops, that should be to the 4th. And I do 35 times 8 gives me 280 x cubed y to the 4th. And that will be the term that contains an x cubed. And then lastly, I can simplify this one. 7 choose 5 is 21. Square both of those to get 4x squared. And then negative y to the 5th is still a negative. So 21 times 4 times a negative 1 is negative 84 x squared y to the 5th. So if I were to multiply this whole thing out, this would be the term that has an x cubed. This would be the term that has a y to the 5th. And that's how we can use all the patterns we've learned today to start to multiply all of these things out really, really, really quickly. And that is all for 7.3 binomial expansion. You can get started on your homework.